In question 5, the problem statement says observe the following pattern and supply the missing numbers. So we are given 11 square equal to 121, 101 square equal to 10201, and 10101 square equal to this number 102030201. And looking at the pattern in this sequence of squares, we have to complete these remaining statements. So we have to find the square of this number. 1010101 square is what? And then in the last part, we have to figure out the square of what number is equal to this number. And to do that, we have to analyze the pattern in the sequence of the first 3 squares. So there are a number of ways to analyze the pattern that is there in this sequence. Let me show you one interesting way to analyze the pattern. So the first square is 11 square equal to 121. Here's how we can think about it. So we have 11 square, and in this number 11, this digit is the first one, so we write it as 1, and this digit is the second one, so we write it as 2. And then because there are no more digits in 11, we complete this string in a symmetric manner. So we have 1, 2, and we write 1 again. So we get 121. Now let's apply this same thinking to the next relationship, 101 square. So we have 101 square, and now this digit here is the first one, so we write it as 1, and then we have a 0, so we write that as 0, and then this digit here is the second one, so we write it as 2, and now because there are no more digits in 101, we complete this string in a symmetric manner. So we have 102, and then we have 0, 1. So we get 10201. Now let's apply the same thinking to the third relationship. We have 1, 0, 1, 0, 1 square. So in this square, we have this as the first one, so we write 1 for this. We have 0, so we write 0. Then we have this digit as the second one, so we write it as 2. Then we have this 0, which we write as 0. And then this one here is the third one, so we write it as 3. And now we have no more digits in 10101, so we complete this symmetrically. So we have 10203, and then we have 0201. So this is what we get for the third square. Okay, so this thinking is what we can apply. This kind of pattern thinking is what we can apply for the remaining 2 squares. So the fourth part is, the fourth square is 1010101 square. So let's complete it using the same thinking that we've used earlier. So we have the first one. For this we write 1, and then we have 0, so we write 0. Then we have the second one, for which we write 2, and then we have 0. And then we have the third one, for which we write 3, and then 0. And then we have the fourth one, for which we write 4. And now we have no more digits, so we complete this string in a symmetric manner. So we take 0, 3, 0, 2, 0, 1. So this is the square of 1010101. Alright, and then finally for the fifth relationship, we are given the square value, and the square value is 102030504030302001. So this is the square value, and we have to write the number whose square is this number. So for the first one, we write 1, and then we have 0. So for this we write 0. For the this digit 2, we write another 1, and then we have 0. And then for the third, for this digit 3, we write 1 again, and then we have 0. And then for this digit 4, we write another 1, and then we have 0. And then for this digit 5, we write one more 1, the fifth one. And then after this, this part of the number 04030201 is symmetric to this part before 5. So we can stop here, and we can say that the square of this number 10101001 is this number that was given to us. And that completes this last incomplete statement. And with this, we have completed question number 5.
To learn more about how QMath can help you crack school and board exams,
Explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.